Hello, Saxon Algebra 2. I almost said 1. But that would be wrong. Saxon Algebra 2, Lesson 68. Scientific notation in calculators is our first topic. We are finally going to use our calculators to do some big wonky calculations, and it'll be fun. John has a strong message for you though, and I back him up 100%. His message is that before we pick up a calculator and start cranking through numbers, we should always estimate the answer. Before calculating. And I abbreviate that as estimate, then calculate. Now, why? Why should we estimate when we're using the calculator to make the process easier? Why, John? So easy, especially when we're using scientific notation and really huge or really small numbers. It's so easy to get thrown off and come up with an answer that has the right digits but the wrong decimal place. So that's why we look at it and estimate before we calculate. Now, I will admit that sometimes I forget and I calculate first. That's okay. Just make sure you go back and estimate before you accept that as your final answer. So, my theory is it's okay if you calculate first. Just double check and make sure your answer makes sense. So, we're going to practice that. I'm going to figure out how to use the keys on your calculator. That's a little awkward because I can't show you my calculator, but I'll draw out the buttons and we can. So here's example 68.1. We have a gnarly problem. It looks like this, but it is a very realistic kind of problem that you would get in chemistry or physics. So you can look forward to this. Draw my exponents big enough so you can see them. We have minus 40,652 times 10 to the minus 8 times that number, I don't want to say it, 0.000324 times 10 to the 15. Okay, this actually is a really little number. This actually is a really big number. Excuse me. We want to multiply them, but Lord, you know how to do that. You're already good at that. What we do is we move the decimal place 1, 2, 3, 4 times. That will be minus 4. That rounds to just plain 4. This will be times 10 to the, what did we say? 1, 2, 3, 4 times. And then we have to multiply it by 10 to the minus 8. And so this becomes minus 4 times 10 to the minus 4. And then this, we move 1, 2, 3, 4 times. It's 3. That would round to 3, not up to 4. And this is 1, 2, 3, 4. That's 10 to the minus 4. And then we have 10 to the 15 as well. So this is 3 times 10 to the 11th. Okay, minus 4 plus 15. Now I'm going to multiply the numbers. I get minus 12 times 10 to that, and I'm going to add these. That would be positive 7. But I have to bump the decimal one more time and make this minus 1.2 times 10 to the first times 10 to the 7th. And so my final estimated answer is minus 1.2 times 10 to the 8th, 1 and 7. Okay? This is review. We've already learned how to estimate using scientific notation. So that part of it is review. That's my estimate. And, you know, like a good Saxon, I estimated before I calculated. Okay, that means I'm ready to calculate. So now we're going to take our original expression. I'm going to write it over since I had to flip. And we're not using our estimate to multiply. We're using the original problem. .0003. Okay? So now we're actually going to calculate. How to use your calculator to do this, go right ahead and do it. You don't have to listen to me. If you don't know exactly how to enter this into your calculator, I'm going to give you some buttons and give it a try and see if you can get it to work. So the first thing we're going to enter is 4,652. This is my button notation. Then you're going to hit the plus and minus to make it negative. Then you're going to hit the multiply, and then you're going to hit -8, and then 10 to the x, okay? That will get you this much. Then you're going to hit times and parenthesis, opening parenthesis. Then we're going to do it all again. Then you'll enter point 0, 0, 0, 3, 2, 4. Don't have to make this one negative. And then it'll be minus, and then it'll be 15 because that's the exponent. Then 10 to the x, just like we did there. Then I don't think you have to do equal again. I think you just do closing parentheses, and then in order to multiply them together, equals. I think that's right. Let me know. Text me if you have any problems with doing this, if you can't get the right answer to come out. But the final answer at the equal sign should be, this is what your display should say. Okay, 131712480. Okay, let's put some commas in that. So it's 131,724,000, and now let's put that back into scientific notation so we can compare it to our estimate. So that would be 1, 2, 3, 4, 5, 6, 7, 8 minus 1.3 times 10 to the 8th. That's the scientific notation estimation version of our actual answer. So this is the estimate of answer. And then we compare that to our estimate. It was 1.2 times 10 to the 8th. Does that sound pretty good to you? That sounds really good to me. So we accept this answer as valid. It was minus 1.2 times 10 to the 8th. That was our estimate. Yay! It works. So, I'm not going to do example 68.2. You already know how to estimate. The estimation is shown in the book, and then you actually follow the same flow. This time, instead of multiplying, we're dividing, and then you do the parentheses on the second half. And the same thing, you go through, you get the answer, you rewrite the answer as an estimate, and then compare that to your estimate and make sure it works. Okay. The hardest part of that is pushing the buttons in the calculator. So if you can figure out how to do that, you're golden. So that was parts A and B combined. Part C is powers and roots. Easier. So let's start with a root example. 68.3. There's a lot of words in here. I'm ignoring them. I'll tell you what you need to know. Evaluate. He makes it sound so easy, doesn't he? Now look at this. It's a radical sign. Inside we have 50.42. What? Since when do we have decimals inside of our roots? That's nasty. And this is, ready? 3.28. We need to find the 3.28th root of 50.42. Not 42, 50.42. I can barely even figure out what that means, let alone the answer. So let's simple this down. First of all, let's simplify this and make it just a cube root. Okay? Now let's think of cube roots that are close to 50. In order to do that, it helps me to just write some of the beginning cubes over here. 1 cubed is 1. 2 cubed, that's 2 times 2 times 2, that's 8. 3 cubed is 27. 4 cubed is what? 64. Aha! Our number is 50. So that means it's going to be somewhere in between 3 and 4. Because it's between 27 to 64. Do you see how I'm mentally simplifying this problem? I'm rounding this down to 3. I look at my cubes, and then I go, okay, so 50 is somewhere between 27 and 64. So that tells me that our answer should be between 3 and 4. That's our estimate. Okay, so now I go to my calculator, I enter 50.42, shoot, I didn't look at my buttons before I did this, so I'm guessing, 50.42, and I think that the button looks like this. So what it's saying is, we'll take it, that's a Y. What the button is saying is you can choose the X and you can choose the Y, and then we'll find whatever that root is. So we enter this first because that's the X, and now we enter the Y value, which is 3.28 equals. And if you do that right, you should get the answer of 3.304. Estimate was between 3 and 4, so that checks. Our estimate looks good compared to our actual answer. Okay, so the trick up here to estimate was to simplify these numbers and look at what we know easily and find where our weird number fits into our nice numbers. All right, let's do two more that are powers instead of roots. Example 68.4. There's an A and a B here. That's why there's 2. Okay, so we have 9.26 raised to the 4.58 power. Okay? Well, I don't know so we could simplify this as 9 to the 5th. I don't know that right off. I don't know my 9 to the 5th powers. But what if we simplified this and made it 10 to the 5th, right? Let's round that up to 10, and then we'll round that up to 5. 5 zeros. So this is our estimate. And we recognize it's probably going to be a little high because we bumped both of those up. But that's okay. So So now what we do is we go to our calculator, 9.26, and this time we want to use the exponent button, which looks like this, I believe. So again, this is the base and this is the power. We put in the x number first, then we hit this button, and then we enter the y value, which is 4.58, and then we hit the equals. And what we get in our display is $26,734.88. That's our answer. Now, there's our estimate. That's a little high, isn't it? Our estimate looks a little high. So we go back over here and go, okay, well, what if we tried finding a range? We'll keep the 10 as the base, but let's try this with a power of 4 so that we get a little bit more of a context for how low this is. 10 to the 4th power looks like that. So what if our estimate is a range? Oh, that's best of all, isn't it? And that looks good. It fits in there nicely. So this was high, just like bottom on the range of our estimate by rounding this down, and now I feel much better. And I will accept it as valid. Part B. This time we have the same base, 9.26, but this time it is to the minus 4.58. Oh. Okay. So, again, we'll do the same thing with our estimate. Let's change this into 10. Let's find 10 to the negative 4, and let's find 10 to the negative 5, and go from there. All right, this is negative exponent. So we rewrite it by flipping it down, right? It's 1 over 10 to the 4th, so that's 1 over 10,000. And the same thing with this. We find the reciprocal, 1 over 100,000. Now, these are in fractions. Our calculator works in decimals. So, I'm going to rewrite our estimates going up here. So that would be 0.000. Let's see, tens, hundreds, thousands, 10,000s. That's where the 1 would be. 1 10,000, right? 10, 100, 1,000, 10,000. And this is 100,000. So again, I'm going to go down here. Point, tens, hundreds, thousands, 10,000, 100,000. Okay, so these are our estimates. It's going to be somewhere between that and that. We take this, we enter it the same way. The only thing we do is we change this to, we would enter the 4.58, and then we would hit the positive negative button to flip that negative, and then we would hit the equal sign. Otherwise it's same as above. And when we do that, we get, according to John, we get 3.74 times 10 to the negative 5th. That's our answer on the calculator. And so let's write that as scientific notation and see if it's between those two. So it's 374. We need to move this 5 times. 1, 2, 3, 4, 5. 1, 2, 4. And so it's bigger than this, right? Because this has 4 zeros, this has 4 zeros. It's bigger than that, but it's smaller than that. So we would accept that answer. It fits in our range. There's the way we estimate it. Okay? So, is it annoying to estimate before you calculate? Yes. Is it hard? No. Honestly, I think in some ways just running these intricate calculations through the calculator is annoying as anything else. But you know what? It's all just a matter of practice and time, and we've got this. So, let me know if you have problems. Instructions for scientific notation, and those are usually pretty helpful. There's some tutorials that can help you get through it if this does not help. But let me know. Thank you.